Everybody, what we're going to do today is work on a worksheet for a more complicated model for population growth. And I'm going to help you go through a few things with VenSim just to make sure that everything is going on the same track as it would if you were in class with me. So we're going to create a new model. My time step's going to be a little smaller than 1 just because we get a more accurate model. And I'm also going to take my final time down to about 20 because I don't need 100 units of time. And my time will be in days. And that's all the changes I'm going to make. Again, you don't have to make these changes. In particular, the units and the final time won't change really much when you look at it. The time step will change things because having a smaller time step means that your model is more accurate. It doesn't mean that it takes longer to run. So here we are, and let's look and see what we're supposed to be doing. So if we come over to our model, we are looking to create a differential equation which says the rate of change of the population is equal to 0.3, that's our growth rate, times our population, times 1 minus our population divided by 10. So we need to go over to our model and we need to have a population level variable and a rate or flow for our differential equation. So we're going to start out with our level variable, which is population, and a rate, which is change in population. And that's going to give us our differential equation. Let's see, we need something to put this 0.3 into, which we have been calling R or K, depending on which version of the worksheet you're looking at. And also, we need something to put this 10 in, and that 10 is usually labeled as M. So we need a couple of extra variables. We need a K, and we need an M. And these need to flow into change in population as well as population. So this is where you want to pause the video and make sure that your VenSim looks like this. Now, your VenSim should look like this, and we're going to continue on. We need to put in our equations. So notice that everything is highlighted in black. That means I haven't put any data in. So the first thing is, according to our model, our K, our growth rate is 3 or 30%, 0.3. And this is going to have units of 1 per time. I said time was in day. And then I could close out of this, or I can come over to this little area and just start putting things in. M is 10, and that's also going to be in units of whatever the population is. Let's say we're doing ducks today. Our population needs an initial value. So our initial value could be something like, well, it needs to be smaller than 10 to be interesting. Let's say 5. And again, this is going to be ducks. And our change in population is going to be K, that was 0.3 times population times, open parentheses, 1 minus population divided by M. And the nice thing is, because we didn't put in 0.3 and we didn't put in 10, we used K and M, that means that this differential equation for our logistic growth will work for any logistic growth model and not just the one that's on our worksheet. Again, our units are going to be ducks per day, and making sure that works. The units of K are in 1 per day. The units of population are in ducks, so K times population is ducks per day. 1 is unitless, and then population is in ducks and M is in ducks. So this is ducks divided by ducks, so that's also unitless. So we're good to go. All right. So we have created our VenSim model. It doesn't look anything different than the last time I told you to pause, but we have now put formulas in. So at this point, we're going to pause the video and make sure you get all of your formulas in there. All right. You've got your formulas in. Let's run the model. You can save it. I'm going to keep going. Okay, fine. You want to save it. It just asked me to rechange the simulation because my computer is kind of busy. So running the simulation, and we can graph our model and see that we have this logistic growth model. We started out at 5, and we have a maximum population of 10. So you can now go through and work on this worksheet where you can change things. If you look at worksheet 3, it has a K of being 0.8 and an M of 5, and then it asks you to start at different places, and so you can work on that. All right, good luck.